The solution to this forgetfulness is client-side storage, specifically the HTML Web Storage API. This is a modern feature built directly into your browser that lets web applications save data locally on your computer. Instead of forgetting everything, a site can store your preferences, shopping cart items, or application state, making your next visit much smoother. But before this API existed, developers used something else.
Before web storage, the primary tool for this job was cookies. While essential for things like authentication, cookies have drawbacks for general storage. They have a tiny capacity, around 4 kilobytes, and most importantly, they are sent back to the server with every single network request, adding unnecessary overhead. Web storage was designed to overcome these limitations. Let's see a direct comparison.
The Web Storage API gives us two distinct tools, local storage and session storage. They function almost identically, but their core difference is data lifetime or persistence. Local storage is persistent. It keeps data even after you close and reopen the browser. Session storage, however, is temporary. It only holds data for a single browser tab session. Once the tab is closed, the data is gone forever. Let's first master the persistent one, local storage. Let's dive into local storage. Think of it as a simple dictionary or a set of key-value pairs, like a filing cabinet built into the browser for your website. Each website gets its own separate storage space. It's perfect for data that needs to stick around indefinitely, like a user's name, a high score, or that dark mode setting. The first step is learning how to add data to it. To save data into local storage, we use the setItem method. This function takes two arguments. First, a key, which is the name you'll use to find the data later, and second, a value, which is the data you want to store. It's crucial to remember that both the key and the value must be strings. Let's store our theme preference. Once data is stored, we need a way to read it back. For this, we use the getItem method. You provide it with the key of the data you want to retrieve, and it returns the corresponding value as a string. If you ask for a key that doesn't exist in storage, getItem won't cause an error. Instead, it will simply return the special value null. What happens if you use setItem with a key that already exists? Local storage doesn't store duplicates. It simply updates the existing value. This is how you change data that's already been saved. For example, if our user switches from dark mode to light mode, we would just call setItem again with the key theme, but with the new value light. To delete a specific piece of data, we use the removeItem method. This is useful when a user logs out and you want to remove their username, or when an item is removed from a shopping cart. You simply pass the key of the item you want to delete, and local storage will remove that key-value pair permanently. Finally, if you need to completely wipe all data for your website from local storage, you can use the clear method. This method takes no arguments and removes every single key-value pair. It's a powerful and destructive action, so use it carefully. It's most commonly used for features like a Reset All Settings button or during a complete user logout process. So far, we've only worked with simple strings. But in real applications, we often need to store structured data, like a JavaScript object containing multiple user settings. If you try to save an object directly using setItem, you'll run into a problem. JavaScript will convert it to the unhelpful string object, and all your data will be lost. Let's see why this happens. The solution to storing objects is a two-step process using JSON, which stands for JavaScript Object Notation. The first step is to convert our object into a JSON string. We do this with the JSON.stringify method. This process, called serialization, effectively takes our complex object and turns it into a flat string that local storage can handle perfectly. With our object now serialized into a JSON string, we can safely save it using setItem. It's just like storing any other string. When we look in the browser storage, we'll see the complete data structure preserved as text. But this string isn't very useful to our program yet. We need to learn how to turn it back into a real object when we retrieve it. To bring our data back to life, we perform the opposite process, deserialization. After retrieving the JSON string from storage with getItem, we use the JSON.parse method. This function takes the JSON string as input and transforms it back into a fully functional JavaScript object with all its properties and values intact, ready to be used by our application. Now that we've mastered local storage, let's revisit its sibling, sessionStorage. The good news is that you already know how to use it. It has the exact same set of methods: setItem, getItem, removeItem, and clear. The only difference is its temporary nature. All data stored in sessionStorage is tied to the current browser tab and is automatically deleted the moment that tab is closed. So why would we ever choose temporary storage? SessionStorage is perfect for data that is relevant only during a user's single continuous interaction with a site. A classic example is a multi-step form. You can save the user's input from page 1 in sessionStorage, so if they accidentally refresh page 2, their data isn't lost. But once they complete the form and close the tab, that temporary data is helpfully cleaned up for them. Now for a more advanced topic, the storage event. This browser event allows you to listen for changes to local storage that happen in other tabs of the same website. When setItem, removeItem, or clear is called in one tab, the storage event fires in all other open tabs for that origin. This enables powerful features like synchronizing a user's login state across multiple windows. With this power comes great responsibility. It is absolutely critical to understand that web storage is not secure. The data is stored in plain text on the user's computer and is easily accessible via JavaScript. This means it is vulnerable to cross-site scripting (XSS) attacks. Therefore, you must never store sensitive information like passwords, API keys, or personal identity data in local storage or session storage. It's also important to understand the scope of web storage. Data is scoped to an origin, which is a combination of the protocol, hostname, and port. This means HTTP example.com has a completely separate storage container from HTTPS example.com or HTTP store example.com. This security feature prevents different websites from reading each other's data. A common question is, how much can I actually store? While the official specification doesn't mandate a specific limit, browsers typically provide about 5 to 10 megabytes of storage per origin. This is vastly more than cookies and is usually plenty for storing application settings and even some cache data. And the great news is, the Web Storage API is supported by every modern browser, so you can use it with confidence. Finally, a crucial skill is knowing how to inspect and debug web storage. All modern browsers include developer tools that let you view, edit, and delete local storage and session storage data for any website. This is incredibly useful during development for verifying that your data is being saved correctly or for clearing out old data during testing. Let's see where to find it. Let's recap our journey. We learned that the Web Storage API provides two powerful tools: local storage for persistent data and session storage for session-only data. We saw how to perform all the basic operations, how to handle complex objects using JSON, and most importantly, we learned to never, ever store sensitive data. You are now fully equipped to build richer, more user-friendly web experiences. Happy coding!